Hello everyone, welcome to 6.5 Limiting Reagents. The learning objective for this section: apply the limiting reagent concept when necessary to stoichiometric calculations. What is the limiting reagent? Whichever reactant would lead to the least amount of the product is referred to as the limiting reagent. This reagent will determine how much of the product is produced. When the limiting reagent is used up, the reaction stops and does not proceed any further, even if you have more of other reagents. I want to continue our analogy with the pancakes to an example where we are using the limiting reagent concept. Feel free to pause your video and try to solve this problem, and then we will go through it. So the question is, how many pancakes can you make with half a dozen eggs and 4 cups of flour? This question we can identify as a limiting reagent question because we are given 2 amounts. We're given amounts of 2 of the reactants. So we have half a dozen eggs. I'm just going to call that 6. We know that means 6 now. And 4 cups of flour. So what we're going to do is we're going to solve this problem, assuming first we have 6 eggs, and then second that we have 4 cups of flour. So let's do the eggs first. So we're going to say we have 6 eggs, and we could go through the dozen to egg thing. We've done that already, so I'm not going to bother with that for this question. So we have 6 eggs, and then we look at the recipe. We see we have 2 eggs necessary for 5 pancakes. So we put 5 pancakes on the top and 2 eggs on the bottom. Looking at the units, the eggs will cancel. So we have 6 times 5 is 30 on the top, divided by 2 gives us 15 pancakes. So if all we were given in the question is how many pancakes can you make with 6 eggs, the answer would be 15. We are also given this information on cups of flour, so let's look at that. So we have 4 cups of flour, and we know from the recipe that we can make 5 pancakes if we have 1 cup of flour. So we use that information. The cups of flour cancel. You know, 4 times 5 divided by 1 is then going to give us 20 pancakes. Okay, so what we've done is we've solved this problem twice. Once based on eggs, once based on flour. Once we've done that, what we then do is we compare the answers. We're comparing here pancakes to pancakes. Whichever one is the smallest is the one that we can do. So 15 pancakes is the smallest. So we can make 15 pancakes with 6 dozen eggs and 4 cups of flour. The eggs are used up before the flour is used up. So even though we could make more pancakes with the flour that we have, because we're limited in the number of eggs, we can only make 15. This is an illustration of the limiting reagent concept, applying it to a recipe. As we've seen earlier, we want to apply not just to a recipe, but to a chemical reaction. So let's look at this chemical reaction. The difference in chemical reactions is that we use the mole concept instead of whatever units we have in the recipe. So as we've done before, we're showing here grams. We need to have units of moles to convert between reactants and products, and then convert back to grams. Go ahead and again take a minute, see if you can solve this problem, and we'll come back and go through the answer. So we have 4.5 grams of H2 mixed with 1.9 grams of N2. And the question is, how many grams of NH3 is formed? And then we're given the balanced equation. Okay, so I'm going to start by writing down some information that could be useful. So I'm going to start, we have moles of H2, and we know the molar mass of H2 from the periodic table. We can calculate that as 2.02 grams. We're also looking for NH3. So we want a conversion factor between H2 and NH3, and we find that in the balanced equation. So we say 3 moles H2 equals 2 moles NH3. And then for the NH3, actually before we get to that, we're going to do the same thing for the nitrogen. So 1 mole of N2 is equal to 28.02 grams. Again, we know how to do that from the periodic table. And then from the balanced equation, we have 1 mole of N2 is equal to 2 moles NH3. Now we're not showing the 1 here, but if we don't show anything, we assume there's a 1. So 1 here, and then the 2 there. And then finally, we have the molar mass of the NH3 is something we can calculate. So 1 mole of NH3 is equal to 17.04 grams. Okay, these are the qualities that we are going to base our conversions upon. If you didn't start with all of these, it's fine to start somewhere and then realize you need something else and adding it to your list. With the limiting reagent concept, remember we are going to be doing this same type of problem twice and then selecting the lowest answer. Let's start with the H2. So we have 4.5 grams of H2. We use the molar mass, so 1 mole of H2 is equal to 2.02 grams. We set it up that way so the grams will cancel for H2. So we've used that conversion factor. We want NH3, so we look for a conversion factor where we do that. So we're showing that one there. So 2 moles NH3 on the top, and then 3 moles H2 on the bottom. Again, important here, not just to say 2 to 3 moles, but moles of NH3, moles of H2, so it's clear how those units cancel. And then we're asked for grams, so I'm going to show how we do that conversion. So 17.04 grams over 1 mole of NH3. It is possible to do this in a way where you're not doing this step yet, and we'll talk about that once we've gone through the whole process. So when you do the math here, you get 25.3 grams of NH3 for your answer. Now, it's a limiting reagent concept, so we do the same type of calculation with the N2. So we have 1.9 grams of N2. We have mole to mass to mole calculation. So 1 mole of N2 on the top, 28.02 grams on the bottom. And then we have, so we use that one, then we have our mole to mole. So we have 2 moles of NH3 on the top, 1 mole of the bottom, and then finally the same molar mass calculation as we had before. So we've used that one now twice. And if we do the math here, we get 2.31 grams of NH3. I suppose I should show how we're canceling units. So the grams here cancel, moles H2 cancel, moles NH3 cancel, and then again down here grams cancel, moles N2, moles NH3. So in each case, we're left with grams of NH3. Again, what we want to do here is similar to what we did with the recipe, is we look at each answer and we select the smallest one. So we can make this much NH3, 2.31 grams. Even though this calculation said we could make more, we can only make whichever one is giving us the fewest So that's telling us that the N2 is our limiting reagent, and the H2 is an excess reagent. There is another way to do this. You could if you wanted to. So you might notice this last step is the same for each of these. You could stop at this point, compare moles, and then proceed on with the smallest moles, which would be this one, and then just do this step and you'll get done. The benefit of doing that is you're actually saving one step. So instead of doing this multiplied by 17.04 grams to each one of them, you're only going to end up doing it one time. The downside, and the reason why I do it this way, is you're kind of interrupting the flow of, if you get kind of into this flow of doing conversion factors, you're kind of breaking it up, making a decision, and then finishing. Either way is fine. I'm showing you one way. The way I kind of prefer, though the book actually I think shows you doing it the other way. So either way is fine as long as you are doing it twice, selecting the smallest number at the end. With the limiting reagent concept, we've gone through a couple examples already. There's one more example I want to look at. But before doing that, I want to talk a little bit about what types of questions you could have. There's actually a larger variety of questions here than in some of the previous types of questions we've looked at. One thing we could be asked to do is, as we've just seen, we're given amounts of two of your reactants and asked to find how much the product you are provided with. That's the type of example we just looked at. So you do a stoichiometry problem based on each reactant, and then you compare them and pick the smallest number as your answer. So we've looked at that type already. Another type of question you might be asked is to identify a limiting reagent or an excess reagent. You're essentially going to be doing the same thing here, but your answer is different. So in the first type of question, the type we've already looked at, the answer is going to be an amount of product. In this type of question, your answer is going to be one of the reactants. Whichever reactant leads to the smallest answer is the limiting reagent. We kind of addressed that a little bit on the previous example. Any other reactant would then be called an excess reagent. Let's look at an example of this. Again, feel free to pause your video, see if you can answer this, and then come back for the answer. Okay, so here's our example. Which substance is the limiting reagent when 1 mole of Na2CO3 is mixed with 1 mole of, I guess I should call them by their names, 1 mole of sodium carbonate is mixed with 1 mole of acetic acid. Okay, you're given amounts of two products, so we know it's a limiting reagent question. We do have the word limiting reagent, and that is the question, is what is the limiting reagent? So that's what we're looking for. This question is not asking us how much of a product we have. It's asking us to identify the limiting reagent. One other thing that's a little different about this question is we're given moles instead of mass. What that means is we have fewer steps because we can get to the mole-to-mole conversion a little bit more quickly. So let's go ahead and set this up. So we have 1 mole of sodium carbonate. And then how we want to do this is we want to convert to one of our products. It actually doesn't matter which one. And for the sake of the math, it doesn't matter at all because it's a 1 for each one of these. So let's go ahead and just pick the first one. We'll put carbon dioxide. So we put 1 mole of carbon dioxide on the top, 1 mole of sodium carbonate on the bottom. Okay, so the math here is just trivial. So the units cancel and we just have 1. So 1 times 1 divided by 1. We would say we have 1 mole of carbon dioxide. Let's do the same thing for the acetic acid. So we start with 1 mole. We have Again, let's go to carbon dioxide. So 1 mole of carbon dioxide. In this case, we have 2 moles of the acetic acid. So we put a 2 there. And the moles of acetic acid cancel. When we do the math, you get 1/2 of a mole of carbon dioxide. This one is smaller. If the question is how much carbon dioxide we would produce, that would be our answer. The question, though, is what is the limiting reagent? So what we do there is the one that made the smallest number is coming from the calculation for the limiting reagent. So we would say that the acetic acid is the limiting reagent because it is the reactant that would be used up first. It's all used up by the time we get here. This one is still going. This one we could call the excess reagent. So if you are asked for the excess reagent, in this case you would say sodium carbonate. So I wanted to illustrate here that in this limiting reagent question we're looking for something a little bit different. We're looking for the identity of the limiting reagent. So be aware you could be asked for that kind of information. Okay, so that is the end of this section. Go ahead and complete worksheet 6.5. If you have questions on this, feel free to ask them on the discussion board and proceed on to 6.6 when you are ready.